guys, we're going to be doing our lesson 4. This is writing equations, two-step equations. So let me see, I'll do number 7. Farmer ships oranges in wooden crates. Suppose that each orange weighs the same amount. The total weight of a crate filled with G oranges is 24.5 pounds. Write an equation that represents the relationship between the weight of the crate and the number of oranges it contains. Well, the total is going to be 24.5 pounds, right? Because it says the total weight. We know the weight of the crate is 15 pounds, so we're going to put that here. Because we have to multiply the the weight of the oranges, which is 0.38, to the number of oranges that there are, which is G. We don't know how many oranges there are, but we do know that we'll have to multiply to 0.38. All right? And that gives us the equation 24.5 equals 15 plus 0.38 times G. Let's go to number 9. At a graduation dinner, an equal number of guests were seated at each of 3 large tables. And 7 late arriving guests were seated at a smaller table. There were 37 guests in all. If n represents the number of people seated at each of the large tables, what equation represents this situation? Well, we know that there are going to be 37 people total. We also know that there were 3 large tables, and there were 7 guests. So let's see. If n represents the number of people seated at each table, we would have to multiply 3 times n. And then if there are 7 more guests, we'd have to add 7. So we'd have the equation 3n plus 7 equals 37. You could also write this as 37 equals 3n plus 7. You could even write it as 7 plus 3n equals 37. As long as those variables are all those terms are in this equation, you're going to be sitting right. Number 11 says Mia buys 4 1/5 pounds of plum. The total cost after using the coupon for 55 cents off the entire purchase was $3.23. If C represents the cost of plums in dollars per pound, what equation could represent this? Well, the total again was $3.23. So let's see, that's going to equal, well, there were 4 1/5 pounds. We're going to have to multiply that by what it costs for each pound, which they said is represented by C. And then, since it was a coupon for 55 cents, we're going to subtract 55 cents from our total. Now, what I don't like is they have a number here that's a fraction with 2 decimals. So I'm going to turn this fraction into a decimal. I know that my fraction or my decimal will start with a 4 because there's 4 in front, and now I have to deal with that pesky 1/5. Well, 1/5 can be represented by remember, every fraction's a division problem. So this is 1 divided by 5. And if I put my decimal here and add 1, I can see that's going to give me 0.2. So I'm going to put that 0.2 after my 4, and now I'm ready to rewrite my equation as 3.23 equals 4.2c minus 0.55. All right, let's go ahead and move now to number 13. With the situation you wrote for problem 12, work if the denominator in the equation were doubled. Oh boy. Well, let's go to number 12. It says write a situation that the equation would represent. Well, this is the equation. I don't even need to know what the situation the person wrote is going to represent to look at this equation and figure that out. See, if I was solving this equation, said, would the situation you wrote for problem 12 work if the denominator in the equation were doubled? Well, in this equation, I'll be solving for G, right? So if I were to do it for 12, I'd be solving for G with 12 instead of 6. I know that sounds confusing, but let's look at it this way. If I'm dividing by 6 over here, I'd have to multiply by 6. So I'd have a new equation of g plus 3 equals, well, 15 times 6. Well, I know 15 times 2 is 30. So 15 times 6 is going to be 90. Then I would have to go to realize I'm going to have to subtract 3 from this side, which means I would subtract 3 from this side. And now I would have g equaling 87. Everyone see how that works? First, I have to multiply this, since I'm dividing by 6 over here, I'd have to multiply by 6 over here and by here. And that's going to give me, let's see, 15 times 6 is 30, or is 60, or is 90. I'm getting tongue-tied here. And then I would subtract 3, which would give me 87. So in this case, I would have to multiply by 12. Does everyone see that? Which means I would have to multiply by 12 over here. And let's just do that real quick. If I multiply by 12 over here, 5 times 2, that's going to give me 10. Carry the 1, that would give me 30. And then 15. And I see that I would have 180. Okay, so that means my equation would now be g plus 3 equals 180. And then I would have to subtract 3 from those sides. And that would give me g equals 177. So when it says would the situation you wrote for problem 12 work if the denominator of the equation were doubled, I would have to say yes. It would just be changed. So if I were to write that, I would have to say the situation would change to fit the new denominator of 12. Sorry about that. Let's see. So the let's see. So the well, that's it. So the total would be multiplied by 12 instead of 6. Okay. I don't know what your situation would be if you were to write that there, but let's just say you were saying that you had you had 6 in an egg carton, a half dozen of eggs. Instead, now you'd be trying to make it fit for a dozen eggs instead of a half dozen eggs. Okay, so let's see. We're off to number 15 now, and we're getting close to the end. In a certain country, the life expectancy of a woman born in 1995 was 80.2 years. Between 1995 and 2005, the life expectancy increased 0.4 years every 5 years. Okay. Let L represent the life expectancy of a woman born in 2005. What equation could you use to represent the situation? This one sounds tricky, but let's break it down step by step here. It says, first of all, in 1995, the life expectancy of a woman born was 80.2. Okay. I know that's might, well, I don't need to put it, it already says it there. Life expectancy of a woman in 1995. Now it says the life expectancy increased 0.5 every 5 years from 1995 to 2005. Well, from 2005 to 1995, is how many years here? We've got 0, with the borrow one, right? That's going to turn this to a 9, and this to a 9. Well, that's actually, no, that'd be 10. So we're talking 10 years. So every 5 years, it says that it increased by 0.4. So that means, well, 10 divided by 5 equals 2. So that means, let's see, that's going to equal 80.2 will equal 0.42, or 0.4, I should say, times 2. Okay, let's see, would that be minus or plus? I might have to rearrange this because this is representing 1995, which people are dying earlier. They're not living as long. So in actuality, I think what I'm going to have to do is state that the life expectancy, which is going to be L here, right? It says L represents the life expectancy of a woman born in 2005, is going to be minus 0.4 times 2. Of course, we could rearrange this equation a number of ways. We could say that, let's see here, we could say that the life expectancy minus 0.4 times 2 equals 80.2. We could also rearrange this if we wanted to and say, if that's so, well, we know we're going to have to go ahead and say that the life expectancy equals, let's see, 80.2 plus 4 times 0.4 times 2. Does everybody see that? Because we're going to have to, we'd have to add 0.42 times 2 over here to this side. Okay? Yeah, so we can either say that added, or, and I think this would probably be the easier one to solve because you'd have all your numbers on one side, but those are the two that I came up with. Last one, it says reasoning. Could two different equations be used to find the value of L? Well, we just solved that, didn't we? Yes. Let's see. And I'm going to say that yes, and it would probably be easier to solve for L since all my terms won't have to be rearranged. All right, rearranged. All righty then. Let's see, do I got any more to do? Nope, 15 was the last one, and that's yours. So I guess good luck in class. See ya.